Okay, good morning, Year 10. Sorry for the delay in getting work to you. I've just been figuring out the best way that I could possibly deliver the work to you. Obviously, at this stage in your school career, it's vital that I keep teaching new material to you, and sometimes platforms such as Heggerty Maths or Dr. Frost Maths might not be the best way, as they may teach it in a slightly different way than what you might be used to. I hope that all of you are well and you're taking care and all of your families are okay, and hopefully this lesson should be just as if you were in class, but obviously in front of your computer instead. So this is a new way to teach for me, so I completely understand if I've done something wrong or you don't understand something. So it's vital that you write me a comment on Show My Homework and I can reply to that possibly in a different video, answering all your questions that you've made to me. So different people will ask me different questions and I can address each of those in a separate video. Obviously, you don't need to watch that video if you don't have a question yourself, but you may still find it useful. So the first topic that I'm going to teach you, we've actually already started in class, which is a sine rule. So I'm going to teach this as if we haven't seen the sine rule before, and then next lesson when I do a cosine rule, it will be in a similar way. Okay, so there will be tasks throughout the video, just like you were in a normal lesson, and when we get to the task, you can copy down the task and you can attempt the task based on the example that I've just given to you. What I will ask you to do is to pause the video at that point and then attempt the task, and then I will give you answers afterwards. I will only give you answers in this video, but in a separate video I will do detailed explanations of how to get the answers, just in case you're a little bit unsure, just like we're in class. Okay, so let's begin. Okay, so if you look at the screen at the moment, we have 6 different triangles, all of which are requiring you to find either a side or an angle. What I would like you to do is just to pause the video for a moment and decide whether you should use Pythagoras' theorem or sine, cosine or tangent to find those missing sides or angles. Okay, so if you unpause the video now, you should see that on the first triangle, we should be using Pythagoras' theorem. On the second triangle, if we label this, then obviously this is a right angled triangle, so this would be the hypotenuse. This is opposite the angle of 57 degrees, so if we're using the opposite and the hypotenuse, we'd be using sine, so we could say that sine of 57 degrees is equal to our opposite side over our hypotenuse, and we could just solve that equation there. On to question 3. First of all, we can see that our angle here is 50 degrees, x is the opposite side, and 9 is the side next to it, so we should be using trigonometry here, and for this one we would be using tangent, so tan of 50 is equal to x over 9 centimeters, and we could solve that to find out what x would be there. On the next one, again we're looking for an angle, so there's a big clue that this must be trigonometry. Firstly, this would be the opposite side, so 8 is the opposite side, 5 is the adjacent side, so we could set up our equation of tan of theta is equal to our opposite, which is 8, over our adjacent, which is 5, and we could solve that to find what theta is. On the next one, we're looking for a missing side. We don't have an angle in this one, so that tells us that this is going to be Pythagoras' theorem. The only thing we have to remember here is that obviously the side opposite the right angle is the hypotenuse, so this is C. It wouldn't really matter which one we called A or B, so we could say that A squared plus 6 squared is equal to 14 squared, and then solve that. The difference on the last triangle here is that this is not a right angle, so we have an angle there of 92 degrees. However, that's not a right angle, so we can't use the trigonometry that you've learned so far. So if it is not a right angled triangle, then we cannot use any of the methods that we've learned so far in the first 5 triangles here. So this is either going to be the sine rule, which I'm going to show you today, or the cosine rule, which you will learn next lesson. So if it's not a right angled triangle, then we're going to label the triangle slightly differently. So here is that same question, but what we're going to do is we're going to look first of all at how we should label the triangle to use the sine rule, or in fact for the cosine rule and for the area formula that we learned in class before. Okay, so here is a sine rule, and this is what it looks like if you were to just have a look at that on the internet or from a textbook or somewhere else, and it doesn't look incredibly nice at the start, but what you have to think about is looking at what the different things stand for rather than just looking at the letters instead. Okay, so over here we have a generic non-right angled triangle, and the only things that are labelled are the vertices and the sides. So in geometry we've labelled the vertices with capital letters since around about year 8. So you can see here we have capital A, capital B, and capital C for this side here. The way that we've labelled the sides is different to how you've seen this before. So for example, this side opposite vertex A we call A, the side opposite vertex B we call B, and the side opposite vertex C we call C. But notice how we use a lowercase letter to notify the sides, and then for the vertices we're using a capital C or a capital B or a capital A. So the sine rule is a proportional relationship between an angle and the side opposite the angle. In any triangle, if you divide a side by the sine of the angle opposite, then you will get the same result whichever angle you use. So what that means, for example, is if you have a look at the formula here, so if you take side A and you divide it by sine of the angle opposite, you would get the same answer as if you took the side B and then divided that by the sine of the angle opposite, which would also mean that if you used the side C and divided it by the sine of the angle opposite, you would still get the same result, just within that triangle, not for every triangle. So it's just the vertices and the angles in that one triangle. Okay, so if I were to use this triangle down here as an example, notice how they've given this angle here as B, but they've used a lowercase b. Normally we would use an uppercase B for an angle, so they may do that sometimes to trick you. And then the side opposite that would be our lowercase b, so lowercase b, the side would be 28. And then I could use A or C for the other two sides and angles. It doesn't really matter which one I use. I will use, just for this one, I'd say that this can be A, side A, and this could be angle A here. And then I could use the sine rule to find out what the missing angle would be there, okay? Or if I were trying to find a missing side and I had the two angles, I could use it as well. The key thing to remember that if you do use the sine rule, it must be an angle on the opposite side and another angle and its opposite side as well. Okay, so you might think to yourself, how do I know whether it's going to be the sine rule? So if we look at these three questions here, we're not going to do these, but we're just going to see whether we should use a sine rule or not. We know that we can only use it when we have an angle and its opposite side. Sometimes you may have to do something to find an angle first of all. So for example, in this first one on the top left, you can see that I have an angle here and a side opposite here, which is 7.9 centimeters. You can also see that I'm looking for this side here, and I have an angle opposite here. So I should use a sine rule on that. So that would be a good one to use a sine rule for. On the next one, again, you can see that I'm looking this time for an angle, so X here, and I have the side opposite. Then I also have this angle here, which is 76 degrees, and I have the side opposite there. So again, that would be a good one to use a sine rule for. If I have a look at the bottom question, I'm looking for this side here, and I do have the angle opposite, but the problem here is that I don't have another angle. I only have one angle given to me, and it's not asking me to find another angle. Therefore, I cannot use a sine rule on this, and this is in fact the cosine rule that I could use to solve this question, which we will learn later in the week. So what I would like you to do with this task is just to pause the video for a moment and just see which of these you could apply the sine rule to and which of them you would use something else for. Okay, it doesn't matter necessarily if you don't know what that something else is at the moment. I just want to know what you would use. So please pause the video now and try to find out. Okay, so if we look at the first one, I'm looking for an angle and I have the side opposite, and then I also have another angle and a side opposite, so I should use a sine rule on that one. So that's absolutely fine to use a sine rule for. On the next one, I'm looking for this angle and there is a side opposite, and then I have this angle and there is a side opposite. So yes, again, I can use a sine rule on this question here. On the next one, I'm looking for this angle here and I have the side opposite, but the problem here is that I don't have another angle. I need two angles involved to be able to use a sine rule. So on this one, I cannot use a sine rule, okay? On the next one, if we look down here, I am looking for this side here, and I have the opposite angle, which is good. And then I don't have another angle to use with one of the other sides. So therefore, again, I'm not going to use the sine rule on that again, that would be the cosine rule that you will learn later on. On the next one, I'm looking for this side here, and I have the angle opposite. And then I also have this angle and the side opposite. So for that one, I could use the sine rule. That would be absolutely fine. On to the bottom ones. So here I'm looking for this side here, and I don't have the opposite angle. And then I do have that this is a right angle, but I don't have anything else. This is quite clearly going to be just Pythagoras' theorem. We don't have any angles other than the right angle in a right angle triangle, so that will not be the sine rule, that will be Pythagoras' theorem. On the last one, we're looking for this angle here. We have the opposite side, but no other angles there. Remember, we need two angles involved if we're going to use the sine rule, so this is not going to be the sine rule either.